My name is Andrii. I'm a lead Android engineer at Lalafo. And today I'm going to talk about Messenger. So about 9 months ago, our company decided to build a new version of Messenger. We already had the Messenger like for 3 years in our app, but many users were leaving our application to WhatsApp. They just were copying the number and going to WhatsApp because there was not enough of features like sending images, real time, some attachments and other things. So we decided to build our own full-fledged Messenger. And as the story goes, every mature company should build a Messenger. Raise your hand who had some experience on writing some chat applications. Oh yeah, some people. Good. Plenty. So we will go through our story, as I told, about transport, Android, architecture, performance, and some learnings we had after this project. So this is looks kind of very simple, only 2 screens. But if you start counting a number of features, it's some of them like we want a real-time messages and send and delivery. We want to share files, delivery status, typing, online status, and list goes on. There is like many of them like pagination, offline send, and we want to delete chats, blacklist users, different types of chats, search, chat with our chatbot Lalafo, and automate responses like Gmail does. So this list is ending, and we went there and said, so let's build this new app. Like probably 2 months is enough for you guys. We said, yeah, it's enough. Let's go and build that. So it passed 9 months, and only like took 9 months around to ship all those features which we wanted to. So our idea was a Telegram like app. We wanted to something as good as Telegram. So as developers, we have seen how fast it is, secure, and many other things, and we wanted to be at least as good as Telegram. But the question you should ask yourself: what needs do you have? Should it be fast? The messenger itself, does it really need to be fast and real-time? Should it support web, client, and synchronize between platforms smoothly without any duplicating messages and lost messages? Should it be really secure? Or all this rest of the features like images, photos, videos? So you should think of it and decide which one do you really need. And when we looked to Telegram codebase, we was like, wow, it's like 5 million lines of code, and we was a little bit surprised inside of it. So another thing is to think about which resources do you have, such as how much time. In our case, it was only 2 months. How much money? Could you hire more people or ask for some expert? Or how much developers you have in your team. And this all leads to different choices, because there is many available solutions already in the market which provide already pre-built chat system on which we can rely upon. And basically it looks like this. So I'd say the more experience you have in chats, the more you want to build something. Because on the left part there is everything which you want to build by your own, starting from a messaging protocol and relying on WebSockets, HTTP streaming, and MQTT, and all the rest of different messaging protocols, and finishing already completely full solution, which is like fully built SaaS systems, which like Intercom, Zendesk. So we do use Zendesk actually for other things like feedback for users on application itself, but it's a different story. It definitely didn't fit our needs in terms of messaging inside of application. This really depends how much resources you have, and some of this, like Socket.io and Meteors, they already provide some kind of library wrapper on top of WebSockets, and you can use that wrapper, and it will be less burden on you in terms of handling reconnects and handling other things, especially support on web and so on, as well as some. If you go a little bit further, you can use some platform systems like PubNub, Firebase, and they will give more ready solution, less bugs probably, less crashes and failures, but the problem with them that they also give less flexibility. So if we want some AI, for example, fraud detection of our messaging, because our users is a C2C marketplace, and they pretty often cheat on each other. They're trying to sell something wrong, so we try to detect this in our chat microservice, and we want to do it on our microservice instead of try to rely on some other parts. So the big thing here is the transport. So if we want to build a really fast messenger, we need to decide which transport we're going to use underneath to communicate with our backend from our application. So there is everybody knows about HTTP. Everybody knows how it's used. It's here basically we make a request, and another user could already send the message, and we will receive updates with new messages. But there is one slight problem. Is there anyone who can help me in the audience? Just who can help me? Like, I just need a volunteer to ask some questions. All right. So imagine you are being a general and me being a soldier. Basically, it's like mobilization, you know. Yeah, and you're gonna ask, and I'm gonna ask you the question: do you have any orders for me? And every time you will respond no. So it's clear? Okay, so do you have any orders for me? Do you have any orders for me? Do you have any orders for me? So imagine if a whole audience started to ask you this question. So it will be quite wasteful in terms of resources, as well as connecting to establishing the connection with the backend. Each time it's quite costly, and it takes a battery, it takes CPU resources, not only on the mobile but also on the backend. And the more such users, the more wasteful resources we have. As well, it's pretty slow, so you can of course set a small timeout, like 30 seconds, but then you will end up with really overbloated server. So this is not the best solution if you want a really great messenger like a Telegram or WhatsApp. So there is some kind of half decision if you need to validate the hypothesis about this messenger system. You can try and build something on top of Firebase Cloud Messaging, so you can have kind of simulate bidirectional communication between client and server. So how it will work: another user will send the message to microservice, chat microservice, and chat microservice will notify Firebase about new message, and then client will receive this push notification, and after it he will request more messages and update the feeds and everything. So it's kind of more real time in terms, and it will help to save some costs, I guess, but there is a couple of things to worry about. The first one, we still do request on HTTP, so it's still slow. And another one is that we are relying on Firebase, which is third party, and the bigger your project, like in our terms we have 5 million of users, and the bigger the project, the more problem you have with this Firebase, because it has own limitation, it doesn't work everywhere, and there is own things to consider. So there is another way is to try some kind of bidirectional transport. I didn't put there a specific implementation because the all bidirectional transport, be it WebSockets or be it HTTP streaming, it has some similar issues and problems with this. How does it work is that our first user is always connected to the server, and as fast as user number 2 will send new messages, user number 1 will receive them. And this is real time, but we are keeping a connection all the time, and this is how it works. Some problems here is that messages can be sent in one order, but then we can receive in a different order. So in HTTP we made a request and we know what we will get back. And here we just get in different kinds of messages all the time, different packets. And we then need to identify what exactly this message is about and do react on the client accordingly. So this is a number of different protocols available. It's really big, and depends on your needs. You can check some your needs there. It's on the top. You can go on Wikipedia. There is just type there messaging protocols, and you will get this list basically, and decide what you need. So if we decided to rely on Socket.io, and our first need was a web client. So our backend CTO was pushing really hard on that we need to implement Socket.io because they have a really good backward compatibility with all the web browsers. So WebSockets wasn't working really well until recently, and some old browsers doesn't support it. So they needed Socket.io as to have backward compatibility with all the browsers. And this backward compatibility is just works in a way that we make a request every 30 seconds or so. This is our first need. There another one. It's fast. Of course it's not that fast as if we would implement WebSockets by our own, or if we would implement some socket protocol, because WebSocket itself carry a lot of burden because it's protocol. It needs a different handshake, upgrades, and other things, and it's all this ceremony. But because we need to support web client, we went through it. But it's definitely way faster than HTTP, and it's save costs on the backend as well. And it handles reconnects, so these three things are pretty good for us. So we went with this. One problem here, though. One problem is Java library has 275 issues, and it wasn't supported for 2 years. And if you have a really strong Android team, you can go for it. But otherwise, you may think about other things. We decided that we can support in case of anything. So far, it works okay. We wouldn't say there is many issues. There is some things we can improve in terms of battery, but overall, it works for us. All right. So, bidirectional transport. So we were saying that we decided to use this bidirectional transport, and many of its implementation has similar roadblocks, which we will eliminate in our way. So these roadblocks, the first one is that I told that we need to identify the request and response, because they all comes from the backend in mixed fashion. So there might be response for one request and then completely for a different. So there is a different kind of packages, and they always come from the backend, and we need to identify which on which relies. So for this, we can use acknowledgement ID, and in this case, so for example, if we will need to implement delivery receipt of the message, we can send this acknowledge ID to the backend, and then another client will send it back. And when we receive this acknowledge ID, we will know that the user was seeing the message, basically. It only not only works for their delivery receipts, but for all requests with basically using this checkmark. So another thing is which can happen is duplicate messages. Because we have many devices, one user can have many devices. He can have iOS, Android, and what happens here is that backend doesn't know which user have sent a message, and this leads to the situation when he will send the message, received message back to all the clients to synchronize the messages. So, for example, we've sent message from first user from Android, and then he will receive this message back, and he already have like 2 messages in the feed, and another user have received 1 message. So to avoid this, we add the socket ID, and it's like common practice, just like socket ID. Then backend can identify which user to which relies and filter the messages. Another thing is quite common is a time sync. So what can happen is when you have one time on one device and it has completely different time zone, and we will receive messages from a backend. There is when the new one from the first Android user, what will happen? It will have different time zone, and because our feed will be sorted by it will jump all the time because the message we've sent on client, but it really reached the server, will be with a different time, and the sort will be mixed all the time, and there will be like all this scrolling back and forth. There is a couple of ways to solve this issue. The first one is we can just timestamp the messages on the backend. And apart from this, when we send a new message, we will check if the last date of all the messages in our feed. So if this time is different, we just use the time of the last message in a feed, and when we send a new message from the client. And then when it reaches the server, it will be time-stamped with the proper time, and it's more or less okay. But still, if we will press like 3 times a button, there will be mixes with time, and user will see it in a not proper order. So to avoid this, we need a little bit different technique. It's more complicated. So basically, what we need, we will send always ping the backend for the time client, and as well as there is a major difference, just store and time and then use it the diff to calculate time to send new message. So this is another technique we can use in this case. All right, so the Android. There is some things about this transport which would be considered in terms of Android, because now the connection is always open, and we should think about other things which can happen on Android. So what happened to me recently? So I had a fight with my girlfriend, and I went to the subway, and I received the notification that I have new on a messenger application, and I press the notification, and the screen appeared, but there was nothing there. So I received notification, but messaging feed wasn't updated. So then after it, I have some glitches on my phone. I restarted the phone, and it started querying everything, and just the battery died. So that's what happened, and I get home frustrated. So there is some things in the platform which we should think about. The first one is the battery, of course, and there is a easy solution is to use to listen for updates of from lifecycle owner, when our application starts, when it stops, and connect or disconnect our socket client, basically. This is what possible to do, and is more or less okay. But there is one issue with this. What happens is that there is a battery, but there is other things when you want to connect and disconnect your client. So another thing might be you receive some Firebase message, or authorization event, if user authorized or not authorized, or there is some reconnect on apps. So all these things, they need to be handled. And it all relates to socket client. And if we will use a callbacks, it won't work that well. But what we found very useful is the state machines in this case. And they works pretty well. So what we have like several different states here. When our app started, when it's entered foreground, background, logged in, all those possible events which can happen. And we have all these listeners registered for this state machine. In this particular example is authorization listener. And all this listener will propagate the state to our state machine. In our state machine, we will just have this one state with many different things which we would like to do. So first, we would like to, for example, if application started, we would like to client a socket client, and we would like to synchronize our unread counter. So we would receive unread counter updates. There is many things which can be done here on other cases. I didn't show them here, but it all depends on your use case. The one thing to keep in mind that there is many things with this socket client. It needs to be either disconnected or some other things, and it really fits nicely here because before of it we had many different callbacks spread across application with this socket client implementation, connector and disconnect, and it was really hard to manage it. And with state machine it's really easier, and I do recommend it. There is an implementation of WebSockets. It's called Scarlet. The team there was, it's kind of like a retrofit, and they do have also they do use state machines to manage the reconnects under the hood. So we was inspired on this, but it wasn't fit our all use case, so I encourage to look at it if you want to get a better insights about how you can use it on chat application. All right, another thing is Foreground Services, and in the usual application, we definitely don't want to use them because it will stay connected all the time and it will drain battery. There is some exceptions if it's some, I don't know, firearm application. It might be a good idea, but in generally using foreground services is no go. Another thing is we can use here is we can use push notifications, and in that situation, when I clicked on push notification and don't receive anything, what would be good to do is to combine this with Work Manager, and as far as we get push notification, we just stop to update our feed, and then we will see the whole feed updated. So it might be a good idea to use Work Manager in this situation and not end up in a situation like I did in the subway. So as you see, there is many features, and it's probably hard to combine all of them, and they're all in 2 screens, and without any proper architecture it might just not work. It's like putting in a BMW engine into Ford Fiesta, you know. So we need something good for this. It's some architecture. Yeah, and in these terms, we was just following industry standards. We're just using already clean architecture in most of our application. And how looks it's our case? We have a data layer with all these streams of data, which we have like from Socket.io, API, database, deep links, Firebase Cloud Messages, and they all may lead to different changes on screen. And then we abstract from them this data layer and have our entities and operation classes in the center, or so, which will be usually used in a UI. So it works well overall. I do recommend probably to use it. It's new features, it's easy to add, so we were adding a couple of new features recently, not by me but also developers, and they found it was really good fit. Although there is one slight issue. So we were using MVP on our app for most of the time, like for 3 years, and you probably know how to use MVP, right? Like most of you had the experience with this. So basically, once the button clicked, we do something in our model through presenters, and we observe our model or request a new model, doesn't matter, and render it to view. There is one issue here. So if we try to have more events here, so as in our messenger, remember we have only 2 screens and there is many operations, and they can lead to different states of UI. So there might be new chats, might be something might be blacklisted, something else, and they all lead to some inconsistency in our UI. So we don't really can say what we should show in a specific moment in our screen. And if we abstract them further, yeah, like all applications do, like a parent presenter, and there's like some order changes and things get even trickier. So it's really hard to scale this thing on a very complex screen. So what we did, we also went with a state machine, and yeah, this is basically the Hannes Dorfman article about, he had this animation about inconsistent states. So there is basically 2 states, error and loading. But in chats it would be even harder. So in our case, we have this state machine. It's making the application a little bit more complicated, but on this kind of screens, which have many events, it's pretty useful idea to use it. And so how does it work, basically? So in this case, for example, we have either item selected, callback from our view to presenter, and then we will propagate the action to our state machine, which has side effects and reducers. So on this action there might be either new state or there might be side effect. And side effect is usually will work with the model. So it will do the same which presenter did, just straight to the model. But in this case we have side effects for this. And then after this we observe some updates and reduce the state. And then we render the state. In this case we have all the time we have a previous state, and we can combine it, and each time we have one specific state, and this really solves this problem. So there is a library from Hannes Dorfman called the RX Redux. Somebody knows about it. Basically quite small implementation, but might be good to watch into it and to see how it works, because it's very simple. I guess in Android community this is the smallest one I've seen, and this is pretty elegant. So I do recommend to look into this RX Redux library to get a better idea. We don't use this state machine approach in every screen, just on chats and on feeds. That's it, because it's kind of really complicated and it takes some time to implement. So I mean, in some places it's inevitable, but in some places if you can avoid it, it will be easier with MVP, and it's faster and more maintainable probably for new people. So this is how it looks in code. Basically, we also, as in example before with the state machine I showed with the battery, We have the sealed class of actions, which will be triggered from view to presenter, and there is different kind of actions like loading, like error, page, and we have state according to this. So this is just a recycler view which renders some items basically. And what's happening here is that we can pass side effects and reducer. And in reducer we will reduce all those actions to some state, and in side effects we just react to each action accordingly. So if there is action about loading new feeds, there will be a load first page side effect basically. In this case, just use GitHub operations, and this is how it works basically. All right, this is an example of one of the side effects. What is happening here, we filter out the specific action which we need to react on, and then we check the previous state on if it contains items or not, and then we do either request next page or the current page, and we just load it. And then after we load, we map it either to page load action, error, and after this, these actions will be mapped to some state which will be displayed on our view. It's a little bit more complicated, more burden, but it works here to use it. So this is a reducer basically. We have this here start loading next page, page loaded action, and we just map it to proper states which we will show in our UI. Kind of a little bit looks like React. Hopefully somewhere in the future we might see something here. So for now we just use plain views and do it in an old fashion, but hopefully in the future we can use compose here to create the whole view out of state more easily. So there is other things is a performance. So for chat, this application is always with the user. And when we open it, we want to be it really fast. It's like probably any messenger for the user is like the most crucial app. So the performance matters here. And in terms of, there is some tricks here I've put. So the first one is not re-render state each time, just distinct it. That's a basic measure. So if there is the same state, was some event triggered, but the state is the same by some reason, we just checked if it's the same with a distinct until changed operator, and we just don't propagate it to UI after all. Another thing is flat view hierarchy. So in our case, we don't use image views, we don't use buttons, nothing like that. So we just use drawables, and we try to render everything on a custom view on a canvas. So what we get after all is just this flat view, which will render pretty fast, much faster than if you will pollute it with different kind of text views and stuff, because text view itself is very slow. It's very complicated to calculate all the widths and heights, and we use layout. There is like in text package there is layout, which is like low-level API to work with text, and we do our own measuring on this, and then receive something like this. So there is a library called Lalafo. I think they do something more complicated, but they get something similar at the end. Lalafo is a Facebook library. They try to generate code in some fashion and they receive also flat views, but without all this ceremony on writing on canvas and using drawables everywhere. In our case, we know how to use drawables, how to use canvas, and with this we can get much smoother scrolling, because our measuring time are really low, and layout also, because we calculate only the things we really need here and nothing else. There is no burden with constraint layout, linear layout, and any other things. And you can look at it. It's one option, because it's also why we went through this. Another reason is that we have a lot of devices in Asia. So there are still users who use Android 4. Around 10% of our users use Android 4. So we're trying to kind of be here more performance oriented. Another thing we can improve is startup time. So instead of, for example, this app component is a dependency component from Dagger, basically. And there is a socket message handler which will do a lot of things and start up socket connection, basically. So what we do here, we try to postpone it as later as all UI will be present to the user. So this kind of API available in us in Android, we can get the looper MyQ and get an add handler to this. And this code will run not on the start of application and only when there will be the looper queue will be free from job. So as you know, there is a lot of jobs which will be pushed on Android because it's main thread, one thread in Android's main thread, and all jobs will be pushed there. So what we can do, we can get this queue, and only when all these jobs are executed, then this will be run. So it's a good idea to initialize most of the things there actually, because it will improve startup time. All right, next one. So hopefully after all the thing, we can build this Vasco da Gama bridge and with a bidirectional transport. But as you see, it's good and nice bridge, but it requires a lot of effort and a lot of thoughts, the proper architecture. Otherwise, it will just not stay long. It may just fall. So, and just because we can build such a bridge with all those tools I showed you before, it doesn't mean we should. So I encourage you to ask yourself about how much resources you have and what is your business needs before starting to build such a big bridge advance. And use the right tool for the job after this. Yeah, and another one, you can think on probably invite some experts from the area and make a fair estimate. Not 2 months, but 9 months. Yeah. So once again, if another thing we work on important actually is designing for flexibility, and architecture that I showed before can help with this, because the messenger, these two screens, it's the app when all the use cases are in 2 screens, and there is a lot of code only in these 2 screens. And we want to build it as flexible as possible, because there is always new features adding up. And so we released the messenger like 2 months ago, and after that we were developing like 2 more major features there, and it's always new features there. If it's and it's only part of our app, so it's important to design for flexibility here. Yeah. So once again, if we can build that bridge, it doesn't mean we should. I'll just vote no to it. And the earlier you can validate how this messenger is important for your business and will it bring the value back, the cheaper it will be, and the more, I don't know, probably a reward you get, maybe a certain salary or something. Yeah, the earlier the better, basically. So, thank you.